So the last 5 or 6 or 8 problems in section 5.9 have to do with right triangles, triangles that have right angles, and I stole a picture of a triangle with a right angle here, and the Pythagorean theorem. Each of the problems is going to use the a squared plus b squared equals c squared Pythagorean theorem that only works for right triangles. And in the world of right triangles, the side opposite the 90-degree angle is always referred to with the letter C, and verbiage-wise, we call that side the hypotenuse. The opposite sides, the sides that are adjacent to the 90-degree angle, we call legs. So one of the sides we're going to call a leg B, and I always make B the longer of the legs. So when I define a problem using the Pythagorean theorem, I'm going to use the a squared plus b squared equals c squared formula. The c is going to be the hypotenuse. It's opposite the 90-degree angle. The a and the b are going to be adjacent to the 90-degree angle, and those sides, usually one is longer and the other is shorter. I'm going to make A the shorter and B the longer, and then C is the hypotenuse. Just to be consistent with myself, that's not set in stone that the A has to be the shorter and the B has to be the longer. It's just I like to be consistent with myself. So I'm going to use that every time in these word problems that deal with the Pythagorean theorem and right triangles. So each one of the problems that we're about to do will just have a right triangle. We'll have C equal the hypotenuse. And I almost made these lengths the same. I pretend this one's longer. B is the longer leg. A is the short leg. There's a right angle, so this triangle obeys the Pythagorean theorem, a squared plus b squared equals c squared. This is knowledge that we're going to need for the rest of the problems in this section. As I read through problem 20, the length of the hypotenuse, C, of a right triangle is 4 more than the shortest leg. More than is a plus word that switches the order, so the 4 is going to go after the plus sign. And then the shortest leg, I put an A in for it. So the first sentence gives me C equals A plus 4. Second sentence, the length of the longer leg, B, is equals 2 more is that plus word again, and you switch. So 2 more, it's going to be plus 2, then the length of the shorter leg, A. So second sentence, just transforming it. Longer leg B is equals 2 inches more. It's a plus that you switch, so the 2 goes after the plus. And what is it more than? Length of the shorter leg, A. So that second sentence gives me B equals A plus 2. And now the disgusting part. I need to do a squared plus b squared equals c squared. So I'm going to plug those numbers, or those expressions, in to the equation. So instead of a squared plus b squared equals c squared, it's going to be a squared plus a plus 2 squared equals a plus 4 squared. That's the nasty equation that I need to solve. I should figure out what a plus 2 squared is by writing it without the square and creating 2 parentheses. Similarly, I should see what a plus 4 squared is by doing the same, creating my 2 parentheses. On the left-hand side, I'm going to leave the a squared, and then I'm going to FOIL. I'm going to go a times a is a squared. a times 2 is 2a, 2 times a is 2a, and 2 times 2 is 4. On the right hand side, I'm going to FOIL. I'm going to go a times a is a squared, a times 4 plus 4a, 4 times a plus 4a, 4 times 4 plus 16. My lord, that's a mess. On the left hand side, each of the a squareds have implied 1s in front of them, and I'm going to clean up the left hand side. I'll add up the a squared and get 2a squared. I'll add up the 2a and get 4a. On the right hand side, I'll add the 4a and get 8a. I need to set this equal to 0. So I'm going to minus a squared, minus 8a, and minus 16. On the left-hand side, the 2a squared minus a squared is really 2a squared minus 1a squared. So it's going to give me 1a squared. 4a minus 8a is going to be minus 4a. 4 minus 16 is going to be negative 12. And I zeroed out the right-hand side. I'm going to factor by sight factoring because there's not a number in front of the squared term. I'm going to look at the factors of negative 12 that I need. Smaller number plus, bigger number minus. And find the pair that give me that negative 4. And that's going to be the 2 and the negative 6. I can sight solve once I get it factored. Or I can do the algebra, but it just seems silly. And just like in the last few problems on the middle video, the part 2, because we're dealing with physical lengths, you can't have negative lengths. So the negative 2 isn't possible. So my answer, A is the short leg. The short leg is going to be 6, and the units are in inches. B is the long leg. The long leg is A plus 2, so it's going to be 6 plus 2, which is going to be 8 inches. And then the hypotenuse is A plus 4, or it's 6 plus 4, which is 10 inches. And I can show you that a squared, which is 6 squared, plus b squared, which is 8 squared, actually equals c squared, which would be 10 squared, just by doing each side separately. The left side, a squared plus b squared, gives me 100. And the right side, c squared, gives me 100. So I can kind of check. All right, let's push through some more. 22, the length of a hypotenuse, C, is equals. So I just jump right into reading. The length of a hypotenuse, C, of a right triangle is equals 2 foot more than the longer leg. More is a plus word that I switch the order. So the 2 is going to go after the plus sign. Before the plus sign is the longer leg. My longer leg is B. So again, A is the short leg. B is the long leg. And C is the hypotenuse. So hypotenuse C is 2 feet more, switch the order, than the long leg. So first sentence gives me C equals B plus 2. Second sentence, the length of the shorter leg, A, is equals 2 feet less than the length of the longer leg, B. Less than is a subtraction, and you switch the order. So it's going to be B minus 2, because the 2 is going to go after the minus sign. Less than is a switcher word, and preceding it's going to be the longer leg, which is b. So I'm going to get a, the short leg, is b minus 2. And then it's just a squared plus b squared equals c squared. And in this problem, in place of the a, I'm going to do b minus 2 squared plus b squared equals c squared, which is b plus 2 squared. I'm going to get rid of both my parentheses by expanding them. And foiling. So left side first, b times b, b times minus 2, minus 2 times b, and minus 2 times minus 2. Right side, firsts are b times b, outers are b times 2, inners are 2 times b, lasts are 2 times 2. Combine like terms. On the left side, the b squareds are really 1b squared and 1b squared, which will combine to 2b squared. The minus 2b's have the same sign, and those will combine to minus 4b. And on the left-hand side, the plus 4 just kind of hangs around. On the right-hand side, the 2b's combined. A trick problem. Good. This is a worthy trick to see. The factoring is so easy, it's hard. So after I clear all those parentheses, because I have the square, I need to eventually get it set equal to 0 and solve by factoring. So I subtracted to get the 0 on the right-hand side. And something happens that's unexpected. It seems like it's bad, but it's good. So on the left-hand side, 2b squared minus 1b squared is 1b squared. Minus 4b minus 4b is minus 8b. And the 4's cancel. This is not a 2 parentheses factoring. This is like a section 5.1 factoring where all I do is factor out the common factor of b and get b times b minus 8 equals 0. Common factors that have a letter give a solution of 0. And the b minus 8 gives a solution of 8. Because these b's represent legs of a triangle, the b equal to 0 is not feasible. So the answer is b is going to be 8, and I guess I should say feet as opposed to foot, but is 2 foot less? 2 feet less would probably be better. 2 feet would be better, but it is what it is. So the b is going to be 8 feet. The a is b minus 2, so it's going to be 8 minus 2, or it's going to be 6 feet. The c is b plus 2, or 8 plus 2, same answers, 10 feet. So my a, my short leg, is 6 feet. My long leg is 8 feet. And my hypotenuse is 10 feet. Not so grammatically nice, but it is what it is. All right, let's just keep plodding along. 24, first sentence. the length of the hypotenuse in a right triangle, C, is, and it feels like there should be more, but it's just is 10 inches. There's no more after the 10 inches, so it's just is 10. That's the end of the first sentence. Second sentence, the shortest leg, A, is 2 inches shorter than the length of the longest leg. Shorter is like less. It's a subtraction when you switch the order. It's 2 less than the longer leg. This is going to be the longer leg B minus 2. It's 2 less than the longer leg or 2 shorter than the longer leg. So A is the short leg of the hypotenuse. B is the long leg of the, A is the short leg of the triangle, B is the long leg of the triangle, and C is the length of the hypotenuse. First sentence says C is 10. Second sentence says the short leg A is 2 less than the long leg, it's B minus 2. And then it asks me to solve. So I'm going to solve this by going A squared, B minus 2 squared, plus B squared, which is just B squared, equals C squared, which is 10 squared. So B minus 2 squared can be written as B minus 2 times B minus 2. 10 squared is 100. On the left-hand side, I'm going to FOIL. I'm going to go first, start B times B, and B times B is B squared. And then B times minus 2 is minus 2B. And then minus 2 times B is minus 2B. And then minus 2 times minus 2 is plus 4. I still have the plus B squared, and I still have the equal 100. Combine like terms on the left-hand side. I'm going to add the 1b squared and 1b squared and get 2b squared. The minus 2b's are both negative, so I'm going to combine those and get a minus 4b. Still have the plus 4, still have the equal 100. I need to get it set equal to 0 so I can solve by factoring. So I'm going to minus 100 from both sides, and that will give me 2b squared minus 4b minus 96 equals to 0. There's a common factor of a 2 that I'm going to factor out. Common factors with letters give a solution of 0. Common factors that are constants without letters don't give a solution. So that 2 is not going to give a solution. It's a common factor that doesn't have a variable. And now I'm going to cite factor. The factors of negative 48 that I'm going to need are 6 and negative 8. Because 6 times negative 8 is negative 48, and 6 plus negative 8 is negative 2. So in my parentheses, I'm just going to speed through that process. Now I can get my answers. The factor of 2, because it doesn't have an x, doesn't give a solution. The factor of b plus 6 gives a solution of negative 6. The factor of b minus 8 gives a solution again of 8. The solution of negative 6 isn't feasible. You can't have negative dimensions. So for the third time in a row, because I need to keep the numbers small and there's only so many groups of nice numbers that work for triangles, my long leg, which is the b, is going to be 8, and the dimensions are in inches as I read through the problem. the short leg is b minus 2, so it's 8 minus 2, which is 6 inches. And I was already told the hypotenuse was 10 inches. I don't even know if I need to include that, but I'll include it. Last problem for the chapter other than the practice test. Let's do 25 together just to knock it out for you. So 25, the length of the short leg in a right triangle A is 3 inches. So that's just A equals to 3. Second sentence, the longest leg B is 1 inch less than the hypotenuse C. Less than is a subtraction and you switch the order. So 1 inch less than the hypotenuse is going to be C minus 1. So first sentence, simple. Short leg is 3, A equals 3. Second sentence, long leg B is 1 less than the hypotenuse. So again, I'm using A is the short leg, B is the long leg, and C is the hypotenuse. I'm using the formula A squared plus B squared equals C squared. And in place of A, I'm just plugging the number 3. In place of B, I'm plugging C minus 1. And I'm leaving the C alone. On the left-hand side, 3 squared is 9. And C minus 1 squared, I'm going to rewrite as C minus 1 times C minus 1. And then I'm going to FOIL. I'm going to do firsts are C times C, which is C squared. Outers are C times minus 1, which is minus 1C. Inners are minus 1 times C, which is minus 1C. Lasts are minus 1 times minus 1, which is plus 1. I'm going to write the left side in a nice order, so I'm going to write the C squared first. I'm going to combine the minus 1C and minus 1C and get minus 2C. And then I'm going to combine the 9 and 1 and get 10. Looks like I need to set it equal to 0 because there's a square. So I'm going to minus C squared minus C squared to get my 0. And then all of a sudden something really pleasant but surprising happens. The algebra destroys the squares, which means I shouldn't have actually set it equal to 0. When you have a linear equation, when the variable has an exponent of 1, you want the numbers on one side, the letters on the other, and you want to solve by dividing. So I suspected I needed to solve by factoring because of the square. But in this really rare problem where the algebra makes the square drop out, I have to go right on the fly and know that I need to flip this around and solve it like something would have been earlier in the semester by dividing as opposed to factoring because the squares canceled out. The units are in inches, so my answer could be C, or the hypotenuse is 5 inches. B is the long leg, and the long leg is C minus 1, so it's going to be 5 minus 1, or it's going to be 4 inches. And then the short leg I was given at 3 inches. I don't probably need to give it again, but I will. Felt like a really monsterly long section doing the video this morning. When we get through the into the semester, I might focus your studies a little bit onto just maybe 2 of the kinds of problems as opposed to all the kinds of problems. So stay tuned just in case I make some comment about trimming up the homework.